Yo, what is good, dev guys? So in the last video, we set up the logic for us to slowly decay our power level over time by using our game mode class. In this video, I want to actually start working on the visual representation of that. And we also want to slow down the character based on his power level. So he will move slower the lower his power level is, and then he will move faster the higher his power level is. So let's go ahead and get that set up. Go ahead, jump into your battery collector character.h file, and let's create two protected float variables. I'm gonna go ahead and copy this here because it's gonna be in the same category. I'm gonna call this my base speed, and this will act as the base speed we will move at if our power level is at 0. And then I'm going to paste that again, and I'm gonna call this my speed multiplier, and this will be the value we multiply our power level by to get our actual speed amount. So let's go ahead and set up the defaults for those inside of our constructor. So come up here, and underneath where we set our power level, let's go ahead and say our base speed is equal to 10. And let's set our speed multiplier equal to 0.65. And where we're going to do this is when we update our power level. Since our power level updates every time we get or lose power, this would be a good place to also adjust the speed amount. So let's go ahead and jump to that update current power level function. And after we update the power level, let's go ahead and say get character movement. And this will return the character movement class that this actor is using. And let me just navigate to a character movement class and try to explain shortly what it is. Okay, so you see it has a network prediction interface, pawn movement component, avoidance interface. And what this component is, this is a movement component that you would have to code from scratch in C#. It comes with jumping, running, crouching, ground friction, network smoothing mode. Like I said, ground friction has velocity. Everything that you would code from scratch about a character or bipedal movement is already done in Unreal for you via this character movement component. And you can take a look at this and see how much it has over 3,000 lines of code in the header file alone. So you can only imagine how deep the source file is. Almost 12,000 lines of code written for you for a automatically networked movement component. And some people will look at this as, I'd rather code this myself, or I'd rather come up with my own solution. And Unreal gives you that opportunity. You can create your own movement component based off of their movement component, or you can just create your own movement component using the actor component class. You can do whatever you want, but you also have a reference that's already written for you. If you wanted to say add a feature that is something that you can't figure out, but Unreal's probably already figured it out for you. So you just go ahead and check out their already existing class and just copy over the code and adjust it to what you need it to be. But inside this character movement class, there is a variable called max walk speed. And here we can say set max, well, not set max walk speed, but we can get the max walk speed. And then we can set it equal to our base speed plus our, I'm gonna put these in parentheses since this is something that happens separately. This is going to be our speed multiplier times our current power level. So this will multiply our speed multiplier by our current power level, and it will give us it will return a float. So if this returns 0, our base speed or our max walk speed will be 10, and you can keep on doing the math to figure out what this will return. So this will adjust our walk speed. And with our base speed set up and our max speed being adjusted via the power level being changed, we also want to go ahead and give the player a visual representation of this happening too. So I want to change the material color of the characters dynamically when their power level changes. And the way that this was done in the original version of this tutorial series was they did this part in Blueprint by using a Blueprint implementable event. And they just called that implementable event inside of this function here. And they did all the logic in Blueprint. But instead, what I'm going to show you is how to do that logic in C++, because I know as a Unity developer coming over to Unreal, I wanted to learn C++ and I wanted to understand the text-based coding before I even jumped into Blueprints. I wasn't that interested in Blueprints when I first started. We might not be the same on that, but I'm gonna show you how to do it in C++. And if you want to see how to do it in Blueprint, I'll leave a link to the original series where you can see that video. But so come over here to your character.h file, and we need to go ahead and override a function that's in the I believe it's a part of U objects. So virtual void on construction, and let's see what this is a part of. It's a part of a actor. Okay, so this is the equivalent to the construction script in Blueprint, and I'll show you that when we go to Blueprint. And we also need to create or declare a dynamic material. So the class for that is a U material, and if I could spell, U material instance dynamic. And we need to, it's a pointer, and it's going to be called our power level dynamic material. And this is the material that we're going to edit the vector parameters on to dynamically and change our material at runtime. So we need to go ahead and give this a U property. I'm gonna actually give it the blueprint read write, and I'm gonna set it in a category that's inside that power category, but it also has its own folder called VFX. And if you do shift and backslash, you'll create this. It's just like doing an OR symbol, but only one slash. And now what we need is a function, and this is something that I may or may not call in blueprint, so I'll make it blueprint callable. And this is going to be update the player's material color. And that's all this function is going to do. And this function will be called inside of that update power level function. So let me go ahead and create the definitions here. Alt insert if you're using Rider, and create definitions, hit OK. And I'm gonna go ahead and call this inside of our update power level function right after we update the speed. So I'm gonna update the player material color right there. So go ahead and call that inside of update power level. And then in our on construction function, let's go ahead and call the super so that base functionality will run. And in here, we need to create a reference to the material that we're going to create a dynamic material of. So follow me here. This is kind of confusing, but as you do these things more, you'll start understanding that it's very simple. So we want to create a U material interface. And I guess that's the hardest part about Unreal, is learning what and where things are. Because in Unity, you kind of create these things from scratch. But in Unreal, you got a lot of things that are already created for you. You just got to find where they are and what they are and how to use them and what they do. And taking more tutorials and learning different things will help that process. So let me continue with this. We're making a U material interface, and this is our material to edit. This is the material that we're going to edit. And we're going to set it equal to the material that is on our player right now. So we need to get our mesh, because that mesh is a skeletal. It returns a U skeletal component. And the skeletal component basically has the mesh, the materials, the bones, everything about the character mesh is in this uSkeletal mesh component. So we need to go ahead and say get material. And in this function, we can pass in the material index because a mesh can have multiple materials. It can have multiple different element types of materials. And I think the max is like 64 or something like that. But we just want to get index 0, which is the first material. And we want to go ahead and we want to create a dynamic material based off of this material and set that to the material instance that we created. So let's do this in code where it makes sense. So our power level dynamic material is equal to, and we need to get that U material instance dynamic class, and we need to call a static function on it called create. And this creates a dynamic material. And we need to pass it a U material interface, which we created right here. That's a parent material. And we need to give it a U object, which is basically like an object to reference this material from, which is this object. So let's pass in our material to edit, and let's give it this object. So now this function here will create a dynamic material, and it'll cache it into our dynamic material variable that we created so we can use it in other places, specifically in this function here. So let's write some pseudocode of what we want to do in this function. First, we want to go ahead and get our material, and we want to set a vector parameter on it. And I'll show you what this vector parameter is when we get into the engine. But I'm gonna get all this coded up, and then I'll run it by you when we open the engine. I guess this is why in the original video they did it in Blueprint, so you can kind of put 2 and 2 together. But just bear with me here. So we're going to get the material and set a vector parameter on it. We also need to get our initial and current power levels. And we need to get an alpha out of that, meaning we need to divide them by each other and get, because when you divide, say if we divided the current power level by the initial power level, we'll get a ratio float from 0 to 1. And actually it will be less than or positive than or more than 1, less than 0, more than 1. It'll go based on how the power level is fluctuating. But we need to get our initial and current power level, and we need to create a ratio or an alpha based off of that. I spelled ratio wrong. Then we're going to use that alpha to interpolate or lerp in between 2 color variables. And that's all we really need to do to update our player material color. It looks confusing here, and it's going to look even more confusing when I start typing out. But like I said, just bear with it. It's a new class that we're working with. It's a new way of doing things. So it's not going to make sense right off the bat. Okay, so getting our material and setting a vector parameter on it is very simple. So we get our material, which is our power level dynamic material, and we go into it, and we want to go ahead and set vector parameter value. And in here, if I can get the tooltip to pop up, we need an F name of the parameter name and an F linear color value that we're going to set the color to. So I know the F name of this parameter is called body color. And for the linear color, we're going to set that up ourselves. So let's go ahead and create a F linear color here. So F linear color. And this is our final color. And the way that we're going to set this color is by using a lerp in between two colors. So first, let's go ahead and get our initial and our current power level and create that ratio. So let's go ahead and say float, and I'm gonna call this alpha, and it's equal to our current power level. So get current power level divided by our base power level. So get base power level, and that will give us our ratio. And let's make this const. And for this lerp, we need to use that U gameplay statics. And oh, actually, I think it's in F math. No, it might be an F linear color. Okay. Okay, yeah, okay. It's in F linear color, and it's F linear color lerp using HSV. So what we're going to give it is a color to come from and a color to go to. So let's go F linear color. And if you look in F linear color, it has colors already given to us. So we can go, let's say we can go from white, which is our base color, and we can go to red or something like that. So let's go to F linear color. Oops. And let's go to red. And the alpha, or the float progress, will pass in as our alpha. So this will lerp using our alpha. And now let's go ahead and say our final color is equal to this. So now we can go ahead and I want to move this underneath because it has to be called last. So now we can go ahead and set that vector parameter and pass in our final color. So now this will go ahead and update our color based on our power level. And let's go ahead and run the editor and see if this is actually going to work. Okay, so just to check and see if it's working, I'm gonna hit play and see if we start changing colors. Okay, we're not changing colors, but our speed is changing. So let's try to figure out why we are not changing colors. We created our linear color, we created our alpha, and then we lerped in between our color using this function here. And let me double check what it is in Blueprint. So let me bring up my character class here and open up the full Blueprint editor, and let's say lerp, and we got lerp linear color. Then we got lerp using HSV. What's the difference between this? Okay, so they're both the same thing. So yeah, there's no other call here. We are calling it, right? Did we call it inside the update? Yeah, we called the update player material here. So this should be running. So let's go ahead and put a log here to see. Let's go ahead and see what our log will say if we pass in a couple of things. So UE log. Whoops. And I want to say log temp. It's going to be a warning. And I wanted to go ahead and say text. And I just wanted to say we have changed the color, just to see if this function is getting called. So let's go ahead and switch over to the editor and compile that. compile successful. So I'm gonna press play, and the function is getting called, but for some reason we're not changing the color. So what that might mean is that we're not using the right F name. So I'm gonna come in here to my character class, come to my mesh, and I'm gonna show you where we get that material from. So I'm gonna get the material and navigate to it. And inside of this material, we should have a vector parameter that's called body color. Now I might be messing up, and maybe I need to wrap this in the F name. And go ahead and say body color. And maybe that's the reason. Bring this here, let's compile. And let me run it. The color's still not changing, but we're calling that. Okay guys, so I found the solution. I just forgot to set our material back to this dynamic material. We created the material, we edited the material, but we never set this material back to the dynamic material that we created. And I wonder if we can do this in the constructor and do it one time, and then that material will update every time instead of setting it every time. So let me put this here just to test real quick. Oops. I'm gonna cut this, and I'm gonna take it up to this constructor, and I'm gonna paste it underneath here. And then I'll go in and I'll build this. And let's see if we still get a color change here. Okay, yeah, that still works. See, our color is changing from red to whatever this color is now, to like this bluish color. Now we can't move until we collect. Let's try to collect these bad boys here. Ugh. Yeah, so as you can see, our color changes as we collect. And if I start over, it's more obvious. So we start red here. We're able to move fast. Just gotta make sure that we don't go to blue. We're moving a little bit slower now, boys. Oh no. Come here, I need juice. I need juice. We're not going anywhere. But yeah, there you go. Now you can play test and find the perfect balance of decay and that timer as well. I still haven't found it, but yeah, in the next video, we're going to keep building on top of this visual feedback for you guys. If you have any questions, definitely leave them inside of the comment section, because I know that this part was a little bit confusing, and I understand. But one thing that I didn't really go into depth about is that something like this parameter here, this is a whole other topic of itself of how materials work and how you can create parameters to dynamically change materials at runtime, and to also have procedural materials. And Unreal is just crazy. When you think about all the things that Unreal has covered for you, it's crazy. It's scary, but it's crazy. So if you guys are ready to continue, and if you're not scared away yet, go ahead and join me in the next video where we start building more visual feedback for you guys. I'll see you guys in the next one. Peace.